What's this not? What's this not going through? Hold on.
Purchase your tracks today. Purchase your tracks today.
Oh, that's why.
Purchase your tracks today.
Hey, Gambler, how are you? Yeah, gambler. I couldn't. I couldn't sleep tonight. So after like an hour and a half of just laying in my bed with my eyes wide open, I decided to try to be productive with my time. Yep. Resume to my regular schedule program. Yeah, I mean, I thought insomnia was like a condition and not necessarily like a infrequent event. But I don't know. Let me see what the definition of insomnia is. Hold up. It's a sleeping disorder. Acute, transient, and chronic insomnia. That has to suck to have chronic insomnia. Isn't that what like Michael Jackson had allegedly? Uh, you know, there's a million ways to die, man. I'm sure people have literally taken themselves out because they probably went crazy. Stick to caffeine, alcohol, don't use nicotine, don't put up with pain. Avoid large meals and beverages before bed. Yeah, that's crazy. Uh, I don't know in the English language. I guess it's just is it sleepless? Hence the movie title "Sleepless in Seattle." Uh, there's also just wide awake. But I think the term is sleepless. Yeah. Yeah. So what I'm working on is I've been updating a number of services um, yesterday for sending me a text message based on uh, what I deem as important enterprise events. So, specifically, when a courier is approved or when an applicant is approved to be a courier, I make sure I receive a text message for that. When when a when a customer places an order and the customer has been successfully charged that order amount, I send myself a text message. Um, right now, I'm sending it. Oh yeah, when a courier uh, submits a payout request, I send myself a text notification. Right now, I'm about to send myself a text notification when a courier decides to cancel a order that they recently accepted for fulfilling. That's what I'm adding right now. And so like I created this SMS module in a notify module. I think it's pretty clean. And I just did a brain dump on um, my blog where I just copy and pasted the code for future reference. So that's crazy. Anyways, uh, let's resume the music. Mm. What is going on? Look like I like it when you do it right. I like the way you do it right there. Look at that. Look at that right there. People think they really know me. No, them nigga lonely. Where you belong? That's only a nigga don't it. Nigga don't it. Don't it. Don't. I spit and then it's got dog. I do my crazy shit. Shut your mouth. People saw and then it's got dog. And then it's got dog. Mama, how? Look, I gets down. People think they really know me, man. I ain't playing around. Nigga, Cleveland's where I'm born. Nigga, Cleveland's where I'm proud. Nigga, Cleveland's where I'm born. Nigga, Cleveland's where I'm proud. And I'm a hound, nigga. Kill. People think they really know me. Yes, bitch, I keep it real, nigga. Meet my homie, meet your girlfriend. Nigga, lonely. Tone it, 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 tone, nigga. Tone it, tone it, tone. You know what? No, they just have to log in to see what the status is. From the streets, people think they really know me. No rip my spit. People think they really know me, man. I'm saying things. Leave my fucking homie, leave your girlfriend fucking lonely. Don't just leave me alone. You're on the phone. People think they really know me, mother. I'm in the zone, nigga. I'm on the zone, Okay. I can check this in. Added notification support for courier cancellation.
Proctor with some announcements before we get into this week's episode. Codebeam STO, previously the Erlang User Conference, celebrates 20 years of Erlang being made open source. Taking place May 31st and June 1st, Codebeam STO is the only conference in Europe bringing the Erlang and Elixir communities together. Some speakers are already announced, and more details, including early bird tickets, can be found at codesync.global. Monadic Party is a 5 days long Haskell Summer School in Poznan, Poland, taking place June 11th through the 15th. They will have 2 tracks, one for programmers that aren't experienced in Haskell and would like to learn it from the basic concepts, the other track for Sonian
primarily in Clojure. Currently,
the 26th through the 28th at the Peabody Opera House. Registration opens in early June 2018, and the keynote speakers have already been announced. The CFP is now open for submissions. It can be found at thestrangeloop.com/cfp.html. And RackyCon will be taking place the 29th and 30th of September. This year, RackyCon will join ICFP and Strangeloop for a week of programming revelry in St. Louis, Missouri at the Union Station Hotel, specifically there in the Jeffersonian and Knickerbocker rooms. 8th RackyCon is the meeting for everyone interested in Racket, a general-purpose programming language that's also the world's first ecosystem for developing and deploying new languages. RackyCon is for developers, contributors, programmers, educators, and bystanders. It's an opportunity for all AI and machine learning,
Why is this
security,
weird? Hold
and
on.
the web. It will be held in St. Louis
that I was doing to
and for all your support. Welcome to Functional Geekery. I'm Russ Proctor, and this week with us we have Zach Tillman. Zach, would you mind telling everyone a little bit about yourself?
Sure. Hey, thanks for having me on. I am a developer. I've been programming for about a decade now, primarily in Clojure. Currently, I'm working as a consultant. I have been writing a book about Clojure called Elements of Clojure, and I'm doing some sort of independent research on some development tools.
And I've seen you in the Clojure community, and you saw your book get announced and seeing people talk about it, and you recently did a full draft available. So got a little bit more steam on that. So figured I'd get you in, get a little bit of background, and get some details about the book, because I've heard some nice things about the book from what people have read so far and have talked about so far. So let's just start with your background. How did you get into software, and how did you get into functional programming?
Well, I played around with computers from, around middle school age, largely QBasic. I like to go and take the Gorillas game where you throw explosive bananas at each other and add little cheats. That was sort of how I got my start. And I found that interesting, but it didn't really quite connect to anything else. There wasn't necessarily any sort of obvious next step there. Until later in high school, I picked up a book on C and started playing around with the sort of open source MUD software, the multi-user dungeons and sort of telnet-based multiplayer games. And I played around with the source code for something called CircleMud for a while. Nothing really ever came of it, but that was really the first, I think, real code base I ever touched. I also started to get really interested in graphics, and so I played around with OpenGL and other stuff and had kind of convinced myself at that point that I wanted to make video games. And so I went off to college to study computer science with the intention of building video games, and sort of went in that direction pretty single-mindedly until my junior year in college. I simultaneously realized the video game industry was kind of a cesspool, and I didn't really want to do that. And also I found the coursework that I was doing to be pretty dull. I remember really vividly I was taking a compiler course, and I was had to write this 40-part recursive descent parser. And it was tedious and trivial at the same time. And I had this moment where I realized that if this was what working as a programmer was, I didn't want to do it. And so I stopped going to class and just tried to figure out, like, what did I want to do? And so for a while, I looked around and sort of in the process ended up getting the equivalent of a minor in philosophy and creative writing before I sort of circled back and realized that while I liked them, I didn't find them to be sort of to light my world on fire any more so than software. And it seemed like there were a lot more paths to success as a software developer than there was as a philosopher or writer of fiction. And so I decided to kind of be a little bit more practical and retook the courses and graduated. And, there was sort of a question in my mind of whether or not working as a developer was going to be as dull as the homework. And luckily it turned out that it wasn't. I quite liked it. My first job was in C#. I was writing desktop software. And I was hired actually specifically because the CEO of the company wanted to create what he called a minority report interface. He wanted to create this sort of 3D interface for video surveillance software. And that seemed kind of cool. So I jumped into that, and then that didn't end up going anywhere. And so I just became very well versed in these sort of like low level 2D rendering routines for Windows. And about 3 years into that, I looked around and realized I was about 2 years past where I really wanted to be on the internals of Windows development. And so I started looking around at what I wanted to do next, what was sort of the next language I wanted to play around with. And my sort of test case for that was trying to build stuff with OpenGL. And so, which is not a very good test case for a language, but that was sort of what I was interested in and what I could kind of use as a framework to learn something. And so I played around with Ruby, I played around with OCaml, and made moderate progress with both of them. But then a coworker of mine who was sort of an old Common Lisp head was very excited about Clojure. This man named Tom Fallhaber, and he got involved very early. He wrote some of the documentation generators for Clojure early on. He wrote the pretty print library for Clojure. And I decided to take a look at it. And I had played around with Scheme a little bit back in school, but it hadn't really clicked for me. It hadn't seemed like something that really seemed practical, I guess. And that was something that I, at the time, valued. And so I tried to play around with it, and I tried to write an OpenGL application in it. And because Clojure is built on top of Java, and because Java has good OpenGL bindings, it was really easy. And even more so, there's a very kind of heavy-duty verbosity to OpenGL, or at least to sort of the immediate mode OpenGL bindings, which tell you to like push a matrix, and then here's a vertex, and here's a vertex, and here's a vertex. And if you do that in C or in Java that resembles C, it's just a lot of lines of code, just over and over and over again, and it becomes kind of sprawling and hard to reason about. And so the syntactic mechanisms in Clojure, the macros, right, that allowed for this sort of ability to abstract away this boilerplate just clicked for me immediately. It made tons of sense to me. And so from that, I started to just kind of get deeper and deeper on these things. And Clojure it did click for me. It did make sense for me. It kind of fit the way that I thought about software. And so I kind of started from there and never looked back. And the next job I got was a very short stint at Google before a Clojure startup approached me and asked me if I wanted to work on Clojure full time, and I jumped at it. So since then,
In my past company, there was a lot of Windows internals too, but mostly in another team. Yet still got some fun Windows details on my face. Yeah, I used to do Microsoft Foundation classes, aka MFC, where you had like this message loop pump. It was weird. Like I used to build. I was on the desktop like feature team, and we were writing user interfaces in C++. It was so cryptic to me. I used to be a C++ programmer. I don't know how, but yeah.
I've done Clojure professionally pretty much exclusively.
So you said you had some intro to Scheme, didn't really click back in college. I can understand where that could be, because I had a similar experience where depending on the teacher you get, they can either sell you why, or it's just use this because we're using this. But you had some OCaml as well that you played with. You had a little bit of Ruby. What was the prompt of going from your C# world into the OCaml and then into Clojure for some of the functional programming stuff? Were you exposed to that a little bit with some of the link stuff where they started introducing lambdas in C#, or was that pre-lambdas and you had to make a jump? So what was that, some kind of boundary between when you went from this, I'm doing C# and I'm doing graphic stuff, and I've been here 2 years longer than I should have been, to going out and venturing with some of these other new languages. And when you finally picked up Clojure, what helped that click?
So yeah, I had been doing desktop UI development in C#. And so I was quite familiar with lambdas, or I think they were called delegates in C# 2.0. And I was also familiar with the link, like IEnumerable sort of stuff, where you could go and you could compose all of these different sort of transforms over the sequence. And it kind of made sense to me. And then I started using Clojure, and then it really made sense to me. Like it clicked for me, like what this was trying to do and how this allowed you to turn these sorts of nested, kind of intertwined for loops into something where each step is clearly called out, and you can sort of move them around and refactor them and insert them, and the sort of separation of concerns there. And in fact, I think that like basically everyone at my job started looking at the code I was writing, which, was C# undeniably, but didn't resemble any of the other C# in the code base. And like, what on earth, what happened, right? What are you doing? What is this? And I think that as with anything where you kind of have a new toy, you want to use it everywhere. And so I very likely overused it, right? I think there's something to be said for matching the style and sort of idiom of the people around you. But I was all in, right? This made sense to me. And I think that, C# had these concepts, right? It's a, quote unquote multi-paradigm language, but it allowed you to write in a fairly functional way if you cared to. And so I think that it was actually far better than if I had, for instance, been using Java, which did not have these sorts of paradigms until fairly recently.
And then you pick up OCaml for a little bit. You picked up Ruby. You said you were trying to do some OpenGL stuff. Nothing clicked. Was that the languages didn't just click with you, or that was you couldn't really figure out how to take advantage of the languages for the OpenGL? And then when you came to Clojure, you said it clicked. And
Here's the link. It's that in here. You can reference that link right there.
Trying to figure out what the exposure of the languages that you had seen in between Clojure, what made them click or not, or why you think, looking back, you didn't pick those up, and what made Clojure special for you. When you saw it, you're like, okay, now I get this.
I think that my complaints here are not particularly well-informed ones. And I think, anyone who's an advocate of OCaml, which I think is a fairly nice language. I should also note, I played around with F# a little bit, which is basically OCaml with null, sort of layered atop the .NET library, because that actually seemed like I might be able to use that at my job. And I kind of advocated for that for about 6 months before I was told in no uncertain terms that it was not going to happen. And so I liked OCaml, and it wasn't actually that it didn't work for me. I thought the tooling was a little bit wonky. I think at that point, that was the first time I actually started playing around with Emacs, because I think the only editor that was sort of community standard was Tuareg mode. The thing I actually remember bothering me the most is the auto currying, because if you ever forgot a parameter to one of your functions, it would just curry, and then the compiler error I would get was nonsense, just really difficult to understand, because this sort of partial function would just kind of cascade through your program until finally it's like, yeah, sorry, I expected alpha, but you gave me this other way more complicated thing. And I guess that, at that point, and I should note, I am not I'm familiar with the sort of Hindley-Milner sort of class of type systems and everything like that, but I'm by no means an expert. But I found that to be hard to reason about. And I felt like I was actually spending more time trying to make the type system happy than the type system was saving me from my own sort of conceptual errors. And it just didn't seem like it was helping me along very much at that level of sort of familiarity. Also, its OpenGL bindings were a little bit wonky. And so it just kind of, it didn't, again, this is a utterly ridiculous kind of acid test to use for a language, but it was one I was using. And so I appreciated it. And I think that what I'd used for graphics prior to that had been C++, which, what was his name? Alexandre Andrescu, or the guy who did all the STL stuff. He had a very type system heavy idea of how to build complex libraries. And so I was kind of moderately familiar with this idea of these interlocking pieces, and the library gives structure that you sort of build top, and it sort of shapes everything above it in this sort of crystalline structure. And I kind of bought it. I wasn't totally sold on it. And I think that my encounter with OCaml made me understand what that could look like without all of the C++ kind of cultural baggage. But it just didn't seem like there was a lot there. Also, I think at the time, the only real employer you could have for that was Jane Street. And so that also seemed like it was not opening a lot of doors.
That makes sense. And it's just one of those things to see what clicks, what doesn't. And if it's just, I got it, but just wasn't feeling it versus I got lost. Because I know I've dug into a couple languages the first time and I hear people talk about Haskell and others where it's like they talk about the deflector shield on it, that if you don't approach it at the right angle, you're going to bounce off and you might have to go in a number of times. But if you said closure was the first thing and you kind of clicked from the early beginning because you had the coworker work on it, what about closure when you started digging in made closure click for you?
Well, so that's actually the interesting question. And I think that early on, because I was using Clojure basically from its 1.0 release. And so, I've been working with it in one form or another for about 9 years now, or maybe closer to 10. And when it was sort of in its younger phase and when it was writing a lot of that sort of Lisp enthusiasm that Paul Graham had kind of planted in the online community, I did have people asking like, okay, so why Clojure? What is Clojure? Why do you like Clojure? And I really struggled to articulate that, I think, because I knew it made sense to me and I really liked the macros. I was very macro happy for a while with a lot of the stuff that I did. And I liked the kind of standard library and how it separated out these problems. But it was sort of more of this intuitive, visceral, I like this reaction than something that I could really put words to. And to jump many years ahead to the book, I think this was maybe my first attempt to really try to put words to what is the central Clojure idiom? What are the things that Clojure sort of helps you get right? And I think that it's difficult, not least because when Clojure was first being released, a lot of the publicity was around its transactional memory, like the sort of concurrency primitives and all this other sort of stuff. And I think that the community took a while to settle on the fact that, in fact, it's just that Clojure has practical, immutable data structures that you can interact with in a fairly dynamic way, which is, I think, still Clojure's sort of unique position in the functional language ecosystem. And I think that's it, really, is that it laid very bare how much you could do with pure, immutable representations of data.
And as you get in and you start developing Clojure, if you're in there in the early days and you've seen the community evolve, I probably looked at it somewhere around 2010, 2011 time frame. So still pretty early on, but I know there were a number of people who had been doing it for a couple of years there and never found any practical application myself for it. It was just one of those things that was the language that helped change how I think, and still need to go back and visit it for some of that macro stuff and all the power that they talk about from the Lisperati, how you can actually write your programs outside in, figure out what you want, and then redrive it and take advantage of some of those macros, because that seems like a useful tool anyway. But as you go in, how did you find that community? Because that's early days, even if you're doing it 9 or 10 years now. From even in 2010, 2011, there still was a lot of churn. Linigan, Cake, I think, a couple of these other tools were coming along back and forth. What was it like if you said the OCaml tooling was rough? You're coming in an early day of Clojure. What was that early days like, and how have you seen it evolve from the early community to where Clojure is now? And there's more options that you can find, full-time jobs. You can even do consulting, as you said, doing Clojure versus the OCaml world where you hear, okay, maybe some Facebook and maybe Jane Street are the places I could think of here, at least in the States, that touch OCaml. What have you seen that evolution like from your perspective as you came in from the early days to today? And now that you've actually started settling on enough time to digest what that looks like, that you've started to be able to work on this book.
So, I mean, there was a lot of churn in the early days. There are a few people who just kind of stepped up and claimed large parts of the ecosystem. And in fact, I think that was part of the reason that I was interested in Clojure was, like, I looked at Ruby, and Ruby at that point was pretty well established. It was pretty much the sort of, I mean, I was in San Francisco. It was kind of the most common language you would see for any sort of new venture. And one of the interesting things that I saw was, the people who were big in the community were by and large the people who just showed up first, right? They had laid claim to something and they were just almost exclusively the guy that was just planted the flag in, I wrote a web server, I wrote a framework. And obviously there are a few that had kind of fallen by the wayside, but seeing Clojure from sort of the early days before a lot of those flags were planted was part of my curiosity about sort of being there. And so very early on, Mark McGranahan came up with a sort of standard HTTP protocol called Ring, which is sort of analogous to Rack in Ruby. And Phil Hagerberg did Linigan. And the Ring stuff was fairly well scoped, and so didn't require a lot of constant maintenance. Linigan was a totally thankless slog that Phil just kind of poured himself into for years before anyone sort of came along and decided to share some of that burden. And I think that there was a lot of churn there, but there was also a lot of excitement. And I think that it was very easy for someone to come in and say, here is a use case that this is not serving. And you would see like a solution for that or a workaround for that within days, right? It was an incredibly engaged group of people who are working to kind of build up this infrastructure. And I was helped by the fact, not in terms of long-term viability, but in terms of the sort of initial speed of development, that most of these pieces of the ecosystem were owned by a single person. And so there wasn't a lot of consensus building. There was just like, if you came and said, I would like to be able to do X, and they thought that was okay, they would help you do X. And so one of the flags that I planted early on, I did write an OpenGL wrapper, but that was not, I think, a particularly valuable piece of real estate. But I had been talking to some people about asynchrony, right? They've been talking about like, what does an asynchronous version of HTTP look like? And obviously, unlike a lot of the interpreted dynamic languages, Ruby has a proper threading model. And so this is not, I think, a burning need within the community, but it was something where, Node had just come out. There was a lot of sort of buzz around this idea of asynchrony. People had somehow convinced themselves that this was just like the right way to solve certain kinds of problems. I had played around with Erlang a little bit in the past. That was one of the other things I kind of tried on, but they didn't even have an OpenGL binding. So, And so I wanted to just kind of think about that. That seemed like a really interesting problem. Like, what does this look like? And it seemed to me intuitively that like Clojure's ability to create these sorts of language level extensions should help there. And so there is a standard library pretty much within the Java ecosystem called Netty, which is built on top of the Java NIO primitives, but creates a much more meaningful set of abstractions atop the kind of ePOL, KQ, asynchronous network interfaces. And so I just wrote a very simple wrapper for that in a weekend called Aleph, which was just like literally instead of returning the HTTP response, you went and you imperatively sent the HTTP response, right? These were sorts of decoupled now. And for whatever reason, I think largely having to do with how hot the idea of asynchrony was and how hot the idea of Clojure was, there was just an enormous response. It was the most pitiful excuse for web server ever. Like it was like 100 lines of code layered atop this. It did a bunch of things incorrectly, but it was just right place, right time. And people got really excited about this, in part because I think they saw this as a way for Clojure to popularize itself, right? Sort of to rise these buzzwords and sort of establish itself as, I guess, a competitor to Node in terms of like, how do you write high performance network stuff in a dynamic language? And so kind of based on the response, I decided to go and try to understand that stuff better, to understand like, how do you write network applications? How do you understand these sorts of protocols? How do you expose them in a way which is not so low level as to require someone to go and read a bunch of RFCs to do anything correctly, but not so high level that it precludes all of the flexibility that protocol affords you, right? HTTP is a good example of this, where you can say, oh, well, you get a request and then you return a response and done. But there are all these little corner cases, all these little lacunae in there, which are like, well, what if someone sends a 100 continue expected? What if you want to do streaming requests uploading at the same time you're doing a streaming response download? What if you want to do WebSockets? What if you want to do all these other sorts of things? And so it very quickly falls outside of this very simple request response model. And so you want ideally to have an API that doesn't require you to load all that complexity in your head, but allows you to access that complexity if it's useful. And so that ended up becoming a major focus of mine over the next 4 years, give or take. That was why I was approached by a startup to ask if I wanted to work on Clojure, because I'd been kind of doing work that had been getting some attention there. And then I just kind of kept on building on top of that and was lucky enough to be able to use my web server library in production at a string of jobs. So it wasn't just a completely theoretical thing. I mean, it wasn't a need. We weren't necessarily using it because it was useful, but we were using it because it was fun, which is, I think, true of most startups. Yeah, so that was sort of how I got into that. That's also how I went from being largely a graphics-oriented developer to becoming a back-end engineer or distributed systems engineer. And so, that was a very fruitful time for me. I learned a lot. And one of the things that I really like about Clojure is that it gives you access to a lot of very capable libraries written in Java, which are often a little more ornate than they have to be, a little bit more complex, a sort of incidental complexity sort of baked into their API. And so an exercise of looking at this and saying, are things built this way because it needs to be that way, or because they just didn't come up with a better way to kind of fold these things together and present this sort of unified interface atop them? And so I would go and I would try to take an existing interface and clarify it. And then I would have to try to understand, okay, did I just elide something that it has value, or did I make it better? And there's a lot of just sort of back and forth there. There's a lot of churn in terms of how I decided to structure these things. And that was just very useful because Clojure makes it very easy for you to build these layers of abstraction and then sort of tear them away and then try to unify them. And it's a very malleable kind of medium. And it helped me understand where are the essential complexities in systems development.
And then you touched on a couple times Clojure being able to take advantage of all the Java libraries. Maybe this is part of your book as part of the elements of Clojure, but where does that fit in? Because I've just following from the outside of the Clojure community, there's been a couple swings of take everything that's Java and wrap it and put a Clojure interface around it versus no, just use the Java. And I've heard the pendulum swing back and forth a couple of times, like when do you do this? When's Clojure? So if you've done this for a while, you started out just wrapping Netty and making it 100 lines of code, which that's still quite a bit of code for Clojure, but it's still not a lot overall. But you've worked on this and extended this 4 years. You've done this elsewhere. Where's that kind of fitting in? Maybe where is that Clojure sweet spot for when do you wrap something versus when do you just use something and when do you make it more Clojure-esque?
So this is something that I talk about or have talked about a lot and tried to decide, because I think that you're right. There was a period of time early on where people just like the idea of camel case just felt gross somehow, right? If there weren't hyphens between everything, then you're doing it wrong. And so people would write these really trivial wrappers over an existing thing just to make sure that they didn't have to feel the Java-ness of it. And I think that that's frankly pointless, not least because often people would just go and expose whatever subset of the API they thought was useful. And in general, if you can just like have a Java object, then you can do all the things with it. And if you can only access it via this existing API, then you can't. And so you're not providing much value other than this sort of weird aesthetic kind of elitism there. And so I don't think that there's a lot of value there. I do think that Clojure as a language for a full stack language makes less sense layered atop something like Java, because I think Clojure, as I said, is a very malleable medium. And I think that there are parts of your code that you want to have that malleability, which are sort of the connective tissue between the different components. But there are also things which having that sort of level of malleableness, having that sort of plasticity doesn't help you. It just makes it harder for you to reason about what's going on. I think that, at some point you're just like, this is a problem. It's very well understood. Here's a solution. It's also very well understood. And this component that I've built to solve this particular problem may at one point cease to be a problem that we care about, right? We might discard the code because the business or the larger problem spaces move on, but we're not going to go and try to tweak it, right? We're not going to go and reach in and try to like twist a bunch of knobs or anything like that. And so for that sort of thing, which in the book, I sort of talk about the difference between an adaptable approach to solving problems and a principled approach, where adaptable code is sort of this graph-like structure of these sorts of very sparse relationships between these things. And it's very easy to go and tweak one part with having these sorts of ripple effects elsewhere in your code. Whereas a principled thing is very hierarchical. And the principles established at the root dictate how everything beneath it is structured and how the problem is solved. And so it's very predictable. If you know that this is generally how the thing is designed, it's very easy for you to reason about if this works this way, then this thing over here on the other side probably works this way. And that's very nice, but that also makes it sort of fragile because you can't go and start like tweaking little pieces of it without having that whole house of cards kind of topple down. And so I think that those are complementary approaches, and you want to have this sort of exploratory stuff coalesce into something more principled over time where possible. But you generally need to have a level of flexibility in your code where you still are figuring stuff out, right? At the frontiers of your problem solving, you do not want to go and try to create a completely rigid, sort of calcified solution. And so to sort of circle back to your original question, I think that Java is pretty good at calcified solutions. I mean, it is. And I mean, Java's not a well-loved language. And I think the kind of faint praise I've damned it with in the past is that it's a very good assembler for the JVM. It's very predictable what it will go and compile down into. It doesn't provide too many abstractions that have sort of unpredictable performance characteristics or sort of memory characteristics or what have you. And its type system is there, right? It's not a good one. No one would claim that it is, but it's adequate. It goes and it saves you from making dumb mistakes, even if it doesn't necessarily allow you to represent complex invariants. And so it's good at making those sorts of principled things. Once you know how to solve a problem, it's sometimes better to just write it in Java than it is in Clojure, because Java makes it clear exactly what it is that you're trying to do. It makes it clear exactly what can and cannot change about this. And so being able to take something which has sort of coalesced and become a little bit more well understood, and being able to take the stuff that is Clojure, which is very flexible, and turning it into something more rigid has value. And so Clojure as the connective tissue between these stable Java components is, I think, its sweet spot. And so it's useful sometimes to abstract over that, right? Because maybe you want to go and pluck out one of those Java components and replace it with a different one. Or maybe you want to pluck it out and you realize that you didn't understand this as well as you thought it did, and sort of fill it in with this sort of more malleable Clojure. And so having these layers of indirection between your Clojure and your Java can have value, but only in as much as you feel like the code is liable to change, as opposed to, Java's gross, don't make me have to acknowledge that it's there. I think that was a answer to your original question of a little bit indirectly.
And I was wondering where that fit in the worldview today, because I see some of those conversations happening with F# and C#. Like, okay, we're going to now wrap everything. And some of that is, well, we want to get rid of nulls. So maybe in that case, when we're trying to model some of this stuff, it makes sense. Or some of these discriminated unions make a little bit more sense. But I also see that in the Erlang and Elixir communities, where certain people will just wrap anything just because they don't want to deal with the other language that is another language. Like, I just only want to think in my language. And so I wrap it. So I didn't know where that was falling with Clojure, looking at another community who's kind of been through those mini skirmishes within the community to say, do we have any good recommendations on when you kind of wrap this or when you do this? Probably the same thing as C and dropping down into assembly at some point of, sure, you can do it. At what point does it make sense to do it? And what point is it just like, let's just stay with this because it makes sense and we've got the power here?
Right. And I think that if we're comparing, say, F# and C#, yes, the fact that F# frankly works better when you don't have null, but it's there. And anytime that you want to go and build on top of the C# ecosystem, which is basically why you have F# and not OCaml, you have to kind of deal with that boundary between them. But I think that that's actually a fairly minor difference. There's a fairly minor impedance mismatch compared to Clojure and Java, where Clojure wants everything to be an immutable map, and Java wants everything to be an object. And those are extremely different worldviews. And so sometimes it does make sense to go and sort of lift that up and say, hey, we're going to go and turn this into this representation here, which Clojure is very able to work with. And then we're going to go and at the boundaries sort of convert it from and to a thing that Java wants. And I think that has a lot of value, but only where there's enough in between, right? Because, I mean, you can go and you can deal with objects. Purity is important at the boundaries. It's not important in the middle, right? Like, you don't need to make sure that everything within a particular sort of abstraction isn't going and mutating stuff. It's only important that that sort of mutation doesn't leak out, that you don't sort of lose that referential transparency. And I think that the community has gotten better at understanding where that does and doesn't matter. And I think that another nice thing is that there is a pretty strong undercurrent of pragmatism to the people who were originally attracted to the language. They wanted to use it because they liked Lisp, but also because they liked Java. And that Venn diagram isn't huge, which, maybe accounts for why the language itself has not taken on the sort of success that other popular dynamic languages have. But it does mean that, a lot of people who are the Lisp purists, right, who want the console to be reified at the silicon level, they're kind of turned off by it. And I think that that's okay, right? They wouldn't have been very happy in the Clojure community anyways.
And we're kind of talking about some of this stuff. That's how I described the book to you before we started recording, which was I've heard people refer to this as there's a lot of good stuff about how to get into Clojure and how to get started and figure some of the ideas out. You got the Joy of Clojure series, you got Programming Clojure, you got Clojure Programming, you got all these others that are going out that are still introducing essentially the sales pitch for Clojure. Then you've got, as you mentioned, Paul Graham, who said, here's why we have Lisp. Like, I bought into the Lisp in general, but to take me from learning that to here's Lisp, and I can do everything Paul Graham or Peter Siebel or all these other people who write about Lisp talk about exercising the power. Yours has been described as here's the book that's that transition, that intermediate that says you understand the syntax, you know how to get stuff done. This is kind of helping you cross that chasm from being, I can use Clojure as a nice functional language that's powerful and a nice saw to, I can essentially now put on my wizard hat. And it helps show some of those special incantations. So, and I've read a little bit of the previews, but do you want to give a pitch for the book, maybe in your own words, of where you find it and what kind of topics it covers?
Sure. Yeah. I mean, so I should go and kind of contextualize this a little bit because I first said that there needed to be a good second book for Clojure back in 2012. And my pitch for that was I was actually at Strangeloop with a number of other Clojure people, and we were talking, and I said there needs to be a Strunk and White for Clojure. Strunk and White's Elements of Style is this kind of book which is short and opinionated and wrong in some cases, right? It's very narrow and prescriptive, but that's okay because it's just trying to go and give you this very narrow set of prescriptions to follow until you feel like you know better, right? Allows you to walk before you can actually run. And I saw with Clojure, in part because I think that the way that Rich Hickey sort of presents his own sort of design ethos lends itself to this idea of there is a right way to do things. There is a thoughtful way to do things. And I think a lot of people didn't want to write Clojure that wasn't properly thoughtful. And so I would see people getting very twisted up about like whether or not they were writing Clojure the right way. And this is especially bad because oftentimes where people were trying to have Clojure be adopted in their workplace, whoever was excited about Clojure would be the person who had to teach people how to use Clojure. And a lot of people who are in that position had this sort of imposter syndrome of like, oh, well, I'm not, an expert in Clojure. I don't really know how to write Clojure well. But then everyone's kind of going to them and saying like, is this right? And so that was bad, right? And so not having something which was prescriptive and narrow and kind of captured these idioms and just said, do it this way until you think you know better seemed like it would be valuable for the adoption, for the sort of health of the community. And so that night in St. Louis, I raced a few other people to go and register elementsofclojure.com on my phone, and I won. And so that was it. I was gonna write a book about Clojure. And a number of years passed without me actually knowing what that book was supposed to be, right? I kind of had a couple of false starts, but what immediately occurred to me after this was, Strunk and White is effectively a style guide, right? Strunk and White is trying to ask, like, how do you write a good sentence, right? And if you're trying to write an essay, if you're trying to write a novel is not just a collection of good sentences, right? There is a set of relationships between those sentences, which matters more, really, in terms of the overall quality of the work.
Okay, I have a meeting and then I'll probably off to eat. We'll complete the podcast episode later. Thanks for the late. All right, we'll catch up, Gambler. Take care. Bye.
Than the individual construction. And likewise for programming, like, yeah, okay, let's agree that, things are intended a certain way, things are named a certain way. But like at the end of the day, what matters is like, what is the connective glue between all these different pieces? And so it wasn't just going to be a style guide, right? I realized pretty early on that it wasn't just Strunk and White, even though it's, the book is still called Elements of Clojure, which leads to some people being like, are you sure you don't want to rename the book? Like, it seems like it's very, and so I've excise any mention of Strunk and White from any of the descriptions of it because I think it just at this point is more misleading than helpful. But once I started to kind of go and think about this, right? So the first topic I really tried to go deep on was names, because like you can go and you can say, okay, if the data represents this, then call it this, right? If it's just a map and it's a generic map, call it M. If it's a generic value that has no actual type, call it X. If it's a sequence of generic values, call it XS. Like, these are standard idioms. Getting these right mean that people who have been writing Clojure for a while will understand implicitly what your code does. It's very helpful to have standards in that way. But there's a deeper set of questions, which is what makes a name good, right? And what makes a name good is not just it follows the idioms that have been established, right? There is something a little bit deeper than just this is what we've sort of decided to do arbitrarily. And I wanted to kind of get at that. And this was in part because, in this time from about 2012 onwards, I was starting to get into more senior roles. And so it was no longer just me writing code and making things work. It was actually trying to mentor people or to go and review the work that they had done. I was now in the job of saying, is your Clojure, good or whatever? And what I found was I had opinions. Like I certainly could look at something and say, I think that you should do this other way, right? This is not the right way to do it. And that felt very clear to me. But then the next question that I would invariably be asked is, okay, cool. Why? Right? Why is your way better than mine? Like I'm willing to believe you, but it would be helpful for me to be able to understand what your thought process is here. And I would be stymied. Like I wouldn't have an answer for that. Right? I wouldn't be able to go and say, oh, this is exactly what my thought process was, right? It was an intuitive understanding, not a sort of completely realized understanding. And that was very unsatisfying for me. It felt like that didn't scale, but also it felt very sort of argument by authority. And I saw this happening a lot in my workplaces where people would disagree on some part of a pull request or, what have you. And it would be settled by like, well, I've been programming for 11 years and you've only been programming for 10 and a half. So like, sit down and be quiet. I'm right. Maybe in 6 months, you'll understand where I'm coming from. And like, clearly that's not true, right? There's not some sort of single convergent path towards an understanding of software, right? There are many people who have many different sort of perspectives on this. And I wanted to create a vocabulary. I felt a lot of people were sort of talking past each other. And so, over time, and as I started looking at this through the sort of the lens of naming, because I decided that my first chapter was going to be about names, I tried to kind of figure out like, what is at the essence of this? Like, what are the actual questions that we're asking when we're asking, is this a good name? When we go and try to compare two names, or when we try to say, if this name is bad, what would make it better? What are we actually trying to get at there? And I had, during my sort of little walkabout in school, sort of pursued some philosophy. And some of the philosophy courses I took were in the analytic school, which is a group of philosophers, including Russell and Quine and Frege and a bunch of people who were sort of logicians and mathematicians. And they wanted to create a very formal understanding of knowledge. Like, what if we start from first principles? What can we get? This is the sort of line of reasoning that led to the Principia Mathematica and other things like that. And they talked a great deal about names. And I was kind of wondering, like, if I go and I read this and I go and sort of distill this, or at least take the pieces that are sort of relevant to the sorts of names we do in software, can I go and provide a framework, not a formula? There's not something that says, let's plug in this and we have a closed form thing that, presto, out pops a name. But at least provide some sort of framework where someone can go and combine their own domain-specific knowledge to be able to come up with a good name, but also be able to explain why the name is good. And so that was what I tried to do. And I tried to do this for names, and it seemed to work pretty well. The free chapter that's available for the book is the first chapter, which is about names. And I published that originally 2 years ago. And I published it 2 years ago just by itself because I wasn't really sure if this approach was going to work for anybody. And so I had spent a fair bit of time writing this, and I had shared with a few friends, but I kind of, was starting to really doubt whether or not this was something which was more than just kind of a weird little vanity project for myself. And so I wanted to just kind of get a broader perspective on it. And so I just threw it out there and saw what people thought. And, by and large, the response was very positive, like unexpectedly so. And so I decided to try to push on and to try to continue in this vein, which was there are certain questions we're constantly asking about software, right? And we use these words. We talk about names. We talk about good names or bad names. We talk about good abstractions or bad abstractions. We talk about how do you build systems. And all of these terms are very foggy. it's very easy for people to talk about abstractions and be talking about two different entire things, right? And to talk past each other without even realizing it. And so I wanted to take these words and try to distill a definition that seemed to sit at the core of how most people used it. But then also talk about, okay, so what are the concerns here? When we say something is about abstraction, what does that mean? When we say that something is composed well or allows for composition, what does that mean? And unfortunately, where philosophy kind of gave a very clear set of guidelines for naming, abstraction was much less well mapped out. The word is used everywhere indiscriminately, but not with any sort of way where it's really been formalized. In fact, if you go and you search for like what is the definition of abstraction, you'll find a bunch of things that like all seem to be kind of circling around the same idea, but are, if you go and take them at their word, lead to very different conclusions about what makes an abstraction good. And also, I think that you can see the same sort of drift in terms of when people and
All right. I'm taking off. Take care. See ya. Bye.